How to use NumPy array indexing for linear algebra. Imagine you have a big grid of numbers and you want to pick out specific pieces to work with. That's where NumPy array indexing comes into play. It's like having a superpower to grab exactly what you need from your data. When working with matrices in linear algebra, knowing how to access and change parts of your arrays makes your calculations much easier. Let's start with the basics. NumPy arrays are zero-based, meaning the first element is at position 0. For one-dimensional arrays, you just put the index in square brackets. For example, if you have an array called R gets the first element. If you want the last element, you can use negative indexing, like R-1. It counts backwards from the end. When you work with two-dimensional arrays, which are like tables or matrices, you use two indices separated by a comma. The first index is for the row, and the second is for the column. For example, R1, gets the element in the second row and third column. This makes it easy to pinpoint any element in your matrix. You can also grab entire rows or columns using slicing. To get the first row, you write R0. The colon means all columns in that row. To get the second column across all rows, you write R1. This is very handy when you want to work with vectors or submatrices. Advanced indexing lets you select multiple specific elements at once. You can use an array of indices to pick out certain positions. For example, if you have an index array like 0, 2, you can select those elements from your array. Boolean masks are also useful. If you want all elements that are negative or meet a certain condition, you create a mask with a comparison like R0, and then use it to filter your data. In linear algebra, array indexing helps you do many things. You can access or change specific entries in matrices or vectors. Extract submatrices for block operations. Pick out rows or columns for transformations. Or apply element-wise operations only where needed. For example, if you have a matrix representing a system of equations, you can extract the coefficient matrix or the constants vector using indexing, then perform matrix multiplication or inversion. Getting comfortable with array indexing means you can handle your data more precisely and efficiently. It's the key to implementing linear algebra algorithms smoothly in Python. From simple element access to slicing and advanced selections, mastering these techniques gives you total control over your data. This makes your calculations faster, clearer, and more organized.